Welcome to Cheap Controls. We make videos on things that we struggled with, hoping to help you so you don't. Consider subscribing and hitting that bell. In this video I'm going to go over a little bit of everything. I'm going to cover variables, memory, and then do a little math. I've set up a simple single screen on the Nextion Display. I have a text box, a float, a number, and then a button so that I can do some things when I run the debug mode. And I also added a variable. Currently nothing happens if you click on the text box. If I run a compile, it compiles just fine. I'm going to start by going over the float. The Nextion Display does not understand decimal points. It has a float value here, but it's all fake. So you assign it a value in the val field, but what you have are these two values, WS0 and WS1. When you click on it, it gives you a little description down here. And what it's really saying is how many spots are there to the right of the decimal. If you leave it at 0, it's defaulted to 20 because it just assumes you want 20, so it puts 20 in there. But if I put 1 in here, it says to the right, so the decimal place will be to the right, but it's actually one space to the left of the decimal point, and you'll see it'll go to 2. The value in that spot is still 20, but it's only showing one digit. In this case, we'll go ahead and show 3, and it'll show 0, 2, 0. In order to fake the float, we use this bottom one, which shows how many spots the decimal point will be to the left, or how many spots to the right of the decimal place we want to show. This can be confusing because when they say left and right, I think of it as decimal points to the left and to the right, but they mean how the decimal point itself is to the left. And we're going to put 1 in here. So in other words, the decimal point will be one spot to the left. And so now it's simulating 2.0 instead of 20. And we still have a 3 up here, so it still wants 3 decimal points, where the decimal point will be 3 points to the right, or 3 places to the right. And just to show you that it's still 20 in here, we're going to set NO, the number field, and do some math on that. So we're going to go down here. We're going to assign a function to this button. We're going to make n0.val equal to x0.val times 10. Compile it. And now we're going to debug. So when I click this, we took 10 times 2.0 and we're going to put it over here. You would expect that to be 20. But it's 200 because even though it has the decimal point, Nextion doesn't know how to deal with that, and the value is still what you assign the value to. So we're really just tricking it for a display only. So when you add this float in here, understand that you're just doing it for display only. We're going to set this to 200 now and get rid of all the formatting. So we'll set this to 0. This to 0. Now this acts just like the number field now. I want to go over a couple of math rules when it comes to how the Nextion Display works, because it doesn't work the way it does in a lot of other languages. We're going to set the float value equal to the float value plus the number value. We're going to add the number value to the current value in the float, and then we're going to assign it to the float value. So when we push this, we'll get 202, and then 204, 206. It will just keep incrementing. That should make sense. It should work pretty much the way. There is a shortcut way where you can do whatever the equal sign. If I want to do an addition, I just put a plus, and then I can eliminate that the x0, and it just knows to take the x val and add whatever's on this side to it. And it operates the exact same way. You can do this with any math function you want. We'll do a divide by. We get 100 because 200 divided by 2 is 100, 50, 25. This is the same as this. You can see we get the same results. Using the shortcut display is fine if you have really simple math, but once you get into something a little more complex, you might want to use the long way to do it and then break it up into lines. And I'm going to give you an example. In this case, we're going to take the float value 200 and we're going to add the value, the number value, which is 2, and then we're going to add 1. So in other words, every time we click on it, we should add 3. Which is what we get. But what if I change this to times? Are we multiplying it times 2 and adding 1, or are we multiplying it times 3? We're multiplying it times 2 and adding 1. But what if we wanted to add the 1 before? What you would do in normal coding is you would put parentheses around it and it would be able to decode to do this step first. But when I compile this, I get an error because it doesn't like that. So what you do is you use a variable. So what we're doing is we're doing the addition up here, assigning it to the variable value, and then we're multiplying it down here. Now we're multiplying this times 3. Another advantage of breaking it up into multiple lines and using the variable is it makes it easier to read. It is a little disappointing that you can't use the parentheses around this to make it around your formulas to make it easier to read. But you're usually not doing a lot of math in the Nextion Display, so in the end it probably really doesn't matter. Next we're going to look at this text box up here. When you look at the text box, you assign the text into here. We'll assign a function to the button, delete this. You use the COV, the convert function, and you put the text first, the object you want to convert, and then where you want to place it. We'll put it on the number. If we put it on the float, it'd be the same. And when you add the 0 on here, that auto formats it to fit the box. So if it's 3 characters, it'll be 3. If it's 10, it'll be 10. And you can see now it said 200. If we hit it again, it's just going to reassign it. The other thing I want to look at is the memory. If you look down here, when I do the compile, it shows the global memory of 4, and then it shows it again down here for page 0. And then it shows the amount of memory used on the page itself. We're going to add a few pages here. So we have 10 pages now on this example. We're going to compile it one more time. And this stayed the same. But the global memory is carried through every page. In this case it's 4, and then each page has 16. So you have to add all this together like they did out here, and that gives you the total amount of memory used for the project. And this is the amount of memory you have. When we make an item global, we're going to make this text global. Then when we recompile it, the global memory will change. Now the amount of global memory is 124, but it's occupied on every single page. So making a variable global really increases the amount of memory used, and it is proportional to the size that you make the item. Like in this case, the text box has a maximum length of 110. If we change this to 10, you'll see that this will decrease by 100. It went from 140 down to just 40, or probably 124 down to 24. So if you decide to make variables global, you really have to pay attention to how much memory you add to them. Also, there was something that I did not mention here in the convert text to value. Right now the text is 200, and the Nextion Display does the best job it can to interpret that 200. If I change the text to not a number and try and move this to this location, we'll see what happens. It reads it as 0 because it can't figure out what the word 20 is. But if you put a number in front of it and run it, it does its best to figure out what you mean or what it can figure out. And in this case, it was able to determine that the 15 were numbers, and it was able to translate it over. If the 15 shows up anywhere but on the front, and you debug it, it can't figure it out. It's not smart enough to find it within it. It also won't find it on the end. It still reads it as 0. It has to be at the beginning. For the most part, if you're doing a conversion, it's best just to plan on it only being a number in there in text form. In this video, we went over how floats aren't real, how you just manipulate the decimal point. We did some math to show that it's best to break up your math into multiple statements and use a variable. And then we also showed the page memory usage, how making something global will use more memory than it being local, and how that can grow rapidly if you're not paying attention to what you're doing. Well, that's about it for this video. If you like what you saw, consider giving me a thumbs up, and also consider subscribing to the channel. Thanks for watching.